3.4, concavity and the second derivative test. Concavity, if your second derivative is greater than 0, it's upward, happy. Happy. If your second derivative is less than 0, it's downward. It's sad. It's a good little smile or frown. It shows you what it means. Now, points of inflections are points where the concavity changes from changes, basically, meaning from, doesn't matter which direction it changes, positive, negative, negative, positive. Points of inflections are just where the concavity changes. And the second derivative equals 0 there. Okay, points of inflection, the second derivative equals 0, or does not exist. Just like critical numbers, it's kind of like the critical numbers of the second derivative. Okay, so points of inflections, these two things are very important, and it tells where concavity changes. Now, if the second derivative equals 0, it does not exist, but it doesn't change concavity, it's not a point of inflection. Got it? It has, sometimes this is true, but it doesn't change concavity. So it's not a point of inflection. It's an important spot, but it's not a point of inflection. So these two have to be true, and it has to change concavity. The second derivative test, basically, if the first derivative equals 0, meaning critical number, correct? And the second derivative exists, meaning I have a point, I can do the second derivative. Then f of c, meaning the point, is a relative minimum when the second derivative is greater than 0. The reason it's a minimum, if the second derivative is greater than 0, doesn't that mean it's happy? And if it's happy, doesn't that mean it's a minimum? Where it's a relative maximum because the second derivative is less than 0. So isn't that saying it's sad? So isn't that a max? Min? It's a minimum because it's happy. It's a maximum because it's sad. That's what it's trying to say. And if you use the first derivative test, you use the first derivative test when your second derivative is 0, because you cannot, when the second derivative equals 0, it doesn't tell us anything. So you have to go back to the first derivative test. So the second derivative test isn't foolproof, but it can be useful if you have your second derivative sitting there, because by the concavity you know if it's happy or sad at a critical number. Again, where the first derivative equals 0 are critical numbers.